Hi everybody. In this video, we're going to talk about parallel lines. Parallel lines are lines that never cross or never have a point of intersection. So let's say we have this line, and they never cross. We'll call this L1 and L2. We would say L1 and L2 are parallel if they have no point of intersection. And the symbol of two lines, vertical like that, is used to represent is parallel to. So here we'd say L1 is parallel to L2. There is a formula for the distance between two parallel lines, and when we say the distance between two parallel lines, we mean the distance of a segment that connects them, which is perpendicular or 90 degrees to both of the lines. So that distance right there is the distance between the two lines. Now, two parallel lines are going to have the same slope. If we were to make a coordinate axis here and draw a line here, and we have another line here, if those two lines have the same slope, they're parallel. So let's say the formula for one line is y equals mx plus b. That is the general formula for any line. And the other line is mx plus c. Notice I used an m here and here. That's because, as I just said, parallel lines have the same slope, so I can put an m in both slots. And these two lines will have different y-intercepts. So the formula for the distance between those two lines is the distance equals the absolute value of b minus c over the square root of the slope squared minus 1. All right? And while we're on the topic, the distance between a line and a point, which would be the length of a segment connecting a point to a line, which makes a right angle to the line. So this distance here, I'll call that capital D. This formula calls for the equation of the line to be written in what we call standard form. This was slope-intercept form. Standard form of a line is ax plus by plus c equals 0. So if we wanted the distance between a line written in standard form and any point, which I'll call x1, y1, that distance can be given by this formula. The absolute value of ax1 plus by1 plus c all over the square root of a squared plus b squared. So two formulas: distance between two parallel lines and distance between a point and any line. All right, let's talk a little bit more about parallel lines. A line that goes through two parallel lines is called a transversal. So here's two parallel lines. All right, and then this red line is an example of a transversal. It just cuts through both. Okay, now say we had another transversal over here. And say we added a third parallel line. So now we have three parallel lines. So if we call this L1, L2, and L3, we say L1 is parallel to L2, which is parallel to L3. Now I'm going to label the distance of this maroon line here A, between this point and this point. And I'm going to label this distance B, this distance C, and this distance D. So there's an interesting property of those lengths, those distances A, B, C, D, and that is that A is to B as C is to D. So the ratios of what are called the intercepts, these segments A, B, C, and D are called intercepts. So the ratio of the intercepts of one line, the A and B, is equal to the ratio of the intercepts of any other line that cut through the same parallel lines. So let's use that property to do an example problem. I'll make 3 parallel lines, and now I'll make 2 transversals going through those. And I'm going to label these points now of intersection here. A, B, C, and these will be D, E, and F. So according to that rule we learned of the ratios being equal, we can say that the length AB is to the length BC as DE is to EF. So, say you were told that AB was 4, BC was 6, and DE was 8. Now, of course, these are not drawn to scale, so these lengths do not look like they reflect these numbers. And we wanted to find EF. We would simply plug our distances or segment lengths into this formula. AB is 4, BC is 6, DE is 8, and EF is what we're looking for. So I'm going to call that X. So 4 is to 6 as 8 is to X. We could cross multiply. 4x equals 48. It's going up here and up here, how we solve proportions. Divide both sides by 4, and we get x has to equal 12. So EF is 12. So a definition of parallel lines, lines that have no point of intersection, a symbol for parallel, those double lines, a couple of formulas for distances, and this relationship between the intercepts of transversals that cut through parallel lines. Hope you got something out of that, and I'll see you soon.